Hello friends, welcome to the course Exploratory Data Analysis for Data Science with R Software. So you can recall that in the last two lectures, we started a discussion on the measuring the central tendency of the data. First, we had considered the arithmetic mean, then we considered median. And we discussed that under what type of conditions they can be used and they will give us better results. Now in this lecture, we are going to continue on the same topic as we had discussed about median in the last lecture. Similarly, we are going to discuss similar type of measures in this lecture. How? If you try to recall, what was median? The median was the value which was trying to divide the entire frequency into two equal parts. When I can divide the frequency into two equal parts and that value is giving us an idea that what is the measure of central tendency of the data, do you think that if I try to divide the same frequency distribution into more than two parts or in different parts, will they also give us some idea? Answer is yes. So we are going to continue our thought process and we will divide the frequency distribution into more than two parts, more than two segments. And we will see how they are going to reflect different type of information and how are we going to compute them on the basis of R software. So essentially we are going to talk about the quantiles, and then like as median or the quartiles or deciles or percentiles, they are the particular cases of this quantile. So in general, we will discuss about the quantiles in this lecture. So we begin our lecture and try to understand this concept. So as you have seen that when we are trying to divide the entire frequency distribution into two parts, then this partitioning value is called as median, right? So median is the value which splits the data into two equal parts. Similarly, can you make here more partition? For example, I can make it here 4 partition. So this is your here, say here part 1 Q1, this is your here second part Q2, then Q3 and then Q4. And similarly, if you want, then we can partition it into more segments, like as I can partition it into 10 segments, or even I can partition it into 100 segments, or depending on the need of the data, I can find out any value on the x-axis here which is going to partition the data into required proportions. So these types of quantities in general they are called as quantile. So quantiles partition the data into different proportions. And this is what we are going to now understand. For example, when the data is splitted into two parts such that at least 25% of the value are less than or equal to that value which is called as quantile, and at least 75% of the values are greater than or equal to that quantile. So that will be called as 25% quantile. Similarly, in case if I try to split the data into two parts such that at least 50% of the values are less than or equal to the quantile and at least 50% of the values are greater than or equal to the quantile, then this is called as 50% quantile. And you have seen in the last lecture that we call this 50% quantile as median, right? So in general, if you try to see, if I try to define any alpha 100% quantile, so I can write down here is like this alpha into 100% quantile, then this is the value which divides the data in proportion such that alpha into 100% proportion is on one side of the value and the remaining 1 minus alpha into 100% values are on the other side of the value. So that means this value is going to divide the data in two proportion, alpha into 100% and 1 minus alpha into 100%, such that alpha into 100% of the values are less than or equal to the quantile, and at least 1 minus alpha into 100% of the values are greater than or equal to the quantile, right? For example, if I try to plot it here, suppose this is my frequency curve, and suppose if I take here this value here. So, this value is trying to say define say alpha here, this is the area alpha, and the 1 minus alpha area is this much. So, this is the value here which is trying to define the or which is trying to partition the entire frequency into two parts. So, this is called as alpha into 100% quantile, right. If I say here for example, this is my 30% quantile, that means this is 30% of the data on left hand side of this value, and this on the other side, this will be 70% of the frequency, and this value is called the 30% quantile, right. So, now the next question is how we can find out. So, if you try to see, in the last lecture we had defined the median. The median was 50% quantile, and we had understood how we had defined it for two types of cases, when the total number of data is an odd integer or an even integer. And the same definition can be extended in general to define the quantiles. So, suppose we have n observation which are denoted by x1, x2, xn, and from there we had obtained the ordered observation which are denoted by here x1, inside the parenthesis we write the 1 and less than equal to x ordered 2 and up to here ordered value of xn, right. So, what are these things? As I told you in the last lecture, that whatsoever be my data, we try to arrange this data into increasing order, and then whichever is the minimum value, that is the first order value, and whatsoever be the maximum value, that is the nth order value, and in between there are other values. With this notation, the alpha into 100% quantile is defined as say x bar alpha is equal to, this is the kth ordered values, kth ordered value. If n alpha is not an integer, then we have to choose k as the smallest integer greater than equal to n alpha. For example, when I took n to be an odd integer, then n by 2th ordered observation was the median, and when n was even integer, then x n by 2 plus, that means the n by 2th ordered value, and x n by 2 plus 1, that is n by 2 plus 1th ordered value, their average was the median. So, the same definition is being extended here, that if n alpha is an integer, then n alphath value and n alpha plus 1th ordered value. So, n alphath ordered value and n alpha plus 1th ordered value, if you try to take the arithmetic mean of both the values, then this will give you the 100 alpha % quantile value, right. So, now what are the application of this definition, which is a very general definition? Now, if you try to divide the total data or total frequency into 4 equal parts, then these quantiles are called as quartiles. Please be careful in my pronunciation, quantiles and quartiles. So, quartiles are the value which divide the given data into 4 equal parts. Let us say we denote them as Q1, Q2, Q3, Q4. It is like this. So, if I try to plot here the data here like this is here the median, and then I try to divide here like this, right. So, if you try to see here, this is 25% part, this is another 25% part which I can denote it by here in say red dots, and then say in here blue stars area, this is here another 25% area, and the last part say here in this like a circle area, and denoting by small circles, this is another 25% of area, right. So, this Q1, Q2, Q3, Q4, they are the values which are going to divide the entire frequency data into 4 equal parts. So, this Q1 is called as the first quartile, which has 25% of the observation. Then Q2 is called as second quartile, which has 50% of the observation median. So you can see here, this is your here Q1, below which we have 25% observation, and then we have here Q2, which has here 25 plus 25 equal to 50% of the observations. And then we have here Q3, which is the third quartile, which has 75% of the observation. Like as here, you can see here, this is your here Q3. So which has here this 25%, this 25%, and this 25% equal to 75% of the observation. So 75% observations are lying in this side of this Q3, and 25% points are lying on the right hand side of the Q3 value. And similarly, the last one is Q4, which is called here as a fourth quartile, and which has 100% of the observation. That means this is here somewhere here Q4, and this contains all the observation from here to here, which is equivalent to, it has 25 plus 25 plus 25 plus 25 equal to 100% of the observations. So this is how, if you try to see a frequency curve of this type that is trying to give you the value here Q1, Q2, Q3 and here Q4 in such a way which are giving you the values that how the data is concentrated across the entire range. And actually, if you try to see, this is more useful. Suppose if you have a frequency curve like this one, then definitely the median is not going to be in the center. So median will be, suppose, for somewhere here, Q2, Q1 may be somewhere here, and Q3 may be somewhere here. So these widths are not going to be the same. So whatsoever be the shape of the frequency curve, but from this quantiles, you can always see how the data is spread across the entire range of the data, right? And then if you try to divide the entire frequency or the data into unequal parts, then these quantiles are called as deciles, D-E-C-I-L-E-S. So it is something like this. You have the frequency curve here, and then you are trying to divide this into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and so on. So this is your here D1, this is your here D2. So now you can see the 100% area has been divided into 10 equal parts. So every decile will contain 10% of the observation. So each of these partitions which are here, each of the partition here, they are containing 10% of the observation. So these deciles are denoted as D1, D2, D10. So D1 is the first decile which has 10% of the observations. For example, here you can see here, this is your here D1. And similarly, if you take here D2, D2 is the second decile. So you can see here, this is your here D2. So D2 is containing 10 plus 10 equal to 20% of the total frequency. So D2 has 20% of the observation. And similarly, if you say D3 contains 30% of the total observation, D4 contains 40% of the total observation. Similarly, your here D5, that is the fifth decile, that will contain 50% of the observation somewhere here, right, D5. This is your here D3 and here D4 and then D5. So what is your D5? Can you identify? So D5 is the value above and below which there are 50% observations. Do you remember that this is called as median? And similarly, if you go to say D6, D7, D8, they are called as 6th, 7th, 8th deciles, and D9 is the 9th decile, which has got 90% of the observation. And then finally, D10 contains 100% of the observations. So if you try to see, you are trying to divide here the entire frequency into 10 equal parts. So these partitions are going to give you some idea about that how the data is concentrated in the entire range. For example, if you have a data curve like this one, which is not a symmetric curve, it might be possible that 10% of the data might be here only, right? So this will give you an idea about how the data is spread and what are the values around which the data is concentrated in some proportion. Similar to this, we have a concept of percentile. Right. So the percentile are those quantiles or they are the values which divide the entire given data or total frequency into 100 equal parts. Right. So if I try to plot a similar curve over here, that means 1, 2, 3, 4 up to here, see here there will be 100 parts and so on. Right. So this first percentile is denoted as a P1 and which has 1% of the observation. Similarly, the second percentile is denoted as say here P2 which has 2% of the observations. And similarly, if you try to say P50 is the 50th percentile which has 50% of the observation, which is nothing but median. And similarly, P90 is the 90th percentile which has 90% of the observation. When I am talking about percentile, as a student, can you recall that? Had you ever used it anywhere? You can recall those who have appeared in different quantitative examinations. Sometimes the qualifying criteria is given in terms of percentile. For example, the examination can declare that all those students who have got the marks more than 80th percentile of their respective board, they can be declared as successful. What does this mean? If you try to see in India, different states have different examination boards for class 10 and class 12. And there is a central board also like CBSE, ICSE, etc. And all of them have got a different pattern of marking. Sometimes you might have listened that someone says, okay, in that board the marking is very difficult and in this board the marking is very easy and so on. So now the problem is that in case if there are suppose two boards and hypothetically suppose I say that board number 1 does a very hard marking that for a small mistake they will deduct more marks, and board number 2 makes a lenient marking, that means for a smaller mistake they will not deduct many marks. So what will happen that if the examination is conducted out of 100 marks and if a candidate has made some mistakes, then the candidates appearing in the board 1, they will be penalized and candidates appearing in the board 2 will get advantage. So now in case if I want to select some students for some entrance examination and we want to allow that which of the students are eligible to appear in the examination at national level. Now how to do it? So one option is that we can declare that any student who has got marks more than 80th percentile of the respective board, then that candidate is eligible to write the exam. So what will happen? Suppose there is board 1 and suppose the frequency data is here like this, and when I say more than 80th percentile, so suppose board 1 has 80th percentile, suppose at say here 60, at 60 marks out of 100, right? And suppose there is another board which is making a lenient marking. In that case, the frequency distribution of their data tells that the 80th percentile in their case is at 90 out of 100 marks. So this means what? If you don't consider their percentile, then the one student is getting 60 marks and another is getting 90 marks. Both have got the similar capabilities, but the student getting the 60 marks out of 100, if I say only the percentage criteria that more than 80% marks candidates are eligible, then the student getting 60 marks will not get a chance to appear in the examination, whereas the candidate may be good. So in order to avoid such problems, we always say instead of using the criteria like 80%, we say the criteria that it is 80th percentile, right? So now at 80th percentile, what will happen? Any student who has got 60 out of 100 or 90 out of 100, both are eligible to appear in the examination. So that is the idea, that now you are trying to read the location where the students are getting eligible. Now in the case of data science also, the data is continuously flowing or the data is very large and data is coming from different resources. And if you want to compare the data, then arithmetic mean may not actually work. For example, if you try to see the income or the salary of a government employee of the government offices in India and say US, Their salaries are different in the sense that the salaries in India, they are in rupees, and the salaries in USA are in dollars. In India, somebody getting a salary of say 2 lakh rupees a month is not equivalent to getting $2 lakhs a month. So in such cases, if you want to compare different types of data set, the one option is that you can use the concept of quantiles, and you can compare the data set with respect to different types of partitions like as quartiles, percentile, decile, etc. Right? Okay. Now the next aspect is how are we going to compute such quantiles in the R software. So we have the command here quantile, Quantile, and then inside the parenthesis we have to give the data, say data vector x, and after that there are certain options. So in case if you do not give here any option, then the quartiles will be reported. But in case if you want to compute say deciles, percentile or any other quantile, then we can use the option here quantile data vector, and then we can use the option here props. Props is a numeric vector of the probabilities. Probabilities always lie between 0 and 1. So in case if I say this frequency curve is an area which divides this entire area into different partition, and these values are called here as in general as quantiles. So if you try to see the total area under the probability curve, which can be seen as frequency curve, or the frequency curve of relative frequencies will be equivalent to probabilities, right? The area, if I try to draw a frequency curve using the relative frequency, then the area under the curve will always be equal to 1. So now if I want to find out here say percentile or decile, I simply have to specify here the values of props, right? So for example, I can use here props equal to suppose 0.7. So that means it will give me the value here, like the entire data is partitioned such that the left hand side has 70% of the value and right hand side has the 30% of the value. So we are getting here the basically the 70th percentile. This is what I mean. And after that we have an option here na.rm, which is can be true or false depending on the whether there are missing data or not. And then after that important operator is type, type, type. Actually type is an integer between 1 to 9, and it actually selects the algorithm which is used to compute these quantiles. You see, definitely when you are getting a data, there are certain algorithms, optimization algorithms, which are used to compute this these partitions. So different people have given, or there are different ways to compute these quantiles, and there are different algorithms for it. So in general, different algorithms will give us different values, but these values are not going to be much different. But instead, if you want to maintain the similarity that everybody is using the same algorithm so that the data is comparable, then you can specify that which of the algorithm is being used to obtain such quantiles. So that's what you can give here, type is equal to 1 to 9, any integer. Right. So for example, if you give here type 1, then the inverse of empirical distribution function concept is used in the algorithm. In that type 2, similar to type 1, but with averaging at discontinuous is used. In type 3, the nearest even order statistics is used, and so on. Right. So that you can see in the help menu, these details are given. So now let me try to compute these quantiles from a data set to show you how it works. So I am using the same data set which I used earlier, that we have recorded the heights of 50% in centimeter, and they are given here 166 centimeter, 125 centimeter, and so on. And I have stored these values in a data vector height. So now if I try to find out the quantiles of this data vector height, then the default function will be quantile, and within parenthesis you just write the variable height data vector. So this is giving you here these quantiles, right? So if you try to see here, 0% quantile is the minimum value actually from where it is starting. Then the first quartile value here is 137.5, and similarly the second quartile here is at 50%. whose value is 146.5. Third quartile has the value 75%, which is 158. And similarly, the fourth quartile, which takes 100% of the data, has the value 166. So what you have to keep in mind that when you are using this operator, it is not giving you 4 values as expected, that 4 quartile value, but it is giving you the 5 values, and the first value is the minimum value, which is because you see what are we doing? We are trying to divide the total range between minimum and the maximum value of data into here different partitions. Right, and that is why the example which I gave you here, that if I have here 2 boards which are given different types of marking, I am trying to divide the area between the minimum and maximum marks of both the boards into equal parts. Right, so this is here like this. Right, so this is what you have to keep in mind. Okay, so now if I want to compute here the quartiles, quartiles means I want here this Q1, Q2, Q3, Q4. So by default choice, it is the quantile function is giving us quartile, but I want to use here the props function, PROBS. So if you try to see, I need to divide the total area into 4 equal parts. So every partition will have 25%. So first partition will have 25% of the data, second partition will have 50% of the data, third partition will have 75% of the data, and here the fourth partition will have 100% of the data. So I can create here a sequence like 0.00, 0.25, 0.5, 0.75 and 1.00. So this type of sequence can be created by the command here seq within parenthesis from 0 to 1 at an interval of say by equal to 0.25. Now I give here quantile, height, and props equal to this sequence value. You can get here the same quartiles which you have obtained here. You can see here this value and the value you have obtained here, they are the same. So this I wanted to show you. Now if you want to find other things over here, I can show you, and this is the screenshot. I will try to show you it on the R console. Suppose if I want to compute here deciles. So deciles means I need to have a sequence of 10 values like as 0.1, 0.2, 0.3 and so on. So what I can create here is the props function as sequence seq from 0 to 1 by 0.1. And I get here the sequence here as 0.1, 0.1, 0.2, 0.3, 0.4 up to here 1.0 at an interval of 0.1 unit. So now if I try to give here the quantile of height and props equal to sequence 0 to 1 by 0.10, then I get here this type of outcome. You can see here this is the 0% which is the minimum value, then the first decile at 10% which is 126.8, second decile at 20% which is the value of here D2 134.6. Similarly here the third decile at 30% partition 140.7, and similarly here the ninth decile which is here 164, and finally the 10th decile which is 166. So you can see here you just need to change only here the props function according to your requirement, right? And this is here the screenshot of the same. And similarly if you want to compute here the percentile, then it is very easy now. You simply have to play with the props function. So you can see here props equal to seq from 0 to 1 by 0.01. So now you will see here this function will give you the value 0.00, 0.01, 0.02, 0.03 up to here 0.99, 1.00. So all the values are from 0 to 1 at an interval of 0.01. Right, and if you try to use it here as say here quantile height props equal to sequence 0 to 1 by 0.01, then you get here. This is your here 0% data, that is the minimum, and then here the 1%, this is your here P1 equal to 122.47. Then this is here the 2% data which is here P2 which is 123.94. And similarly if you try to see here, this is here 95% percentile which is here P95 which is equal to 165. And similarly you can see here this is here P99 which is equal to here 166.00. So you can see here now you have divided the entire data into say this 100 such parts, and here are the values of P1, P2 up to here P100, right. And this is here the screenshot of the same thing, and I will, yeah, it is you can see here it here more clearly, and I will try to show you this on the R console before we move forward. So let me try to first store this data in the R software. So I copy this data height and I store it here. You can see here this is here height, HEIGST, this is the data, right. Now if I use here the direct function here, say here quantile over this height, so what do you get here? Quantile over the height, this is here like this. And in this, if you try to, these are the quartiles, and if you try to use here the sequence is equal to sequence, that we say that is the value of the props, PROBS is equal to SEQ from 0, or I can write it better, from equal to 0 to equal to 1, and by is equal to 0.25. And you will see here what do you get here. These are the same values which you have obtained here. And now if you want to find here Deciles, what you have to use? You simply have to change this 0.25 to 0.1, right, 0.1 for clarity. So you can see here this is the, these are the 10 values. And similarly, if you want to obtain here percentile, so you can make it here by is equal to 0.01. So you can see here these are the percentile. And suppose on the other hand, if you want to know only say here some particular this quantile. So for example, if I want to know only the 47 quantile, so I can say here props equal to 0.47, and you will see here this is here 145.03, and you will see these quantile values, they are also used when we try to conduct different types of test of hypothesis. Right, although we are not going to consider this aspect over here, but anyway, right. So I have shown you all these things on the R console now. Now let me try to take here one more example when the data from this data set are missing. Under that type of situation, how will you construct such quantiles? So what I have done here from the same data set, I have made the first two values as missing. So we have here 48 values available, in which we have the heights of 48 persons measured in centimeter, and I am storing this data as a height.na, HEIGST.na. And now I try to just repeat the same exercise what I have done earlier, that I will say here if I use here quantile height.na, it will give you error because there are missing values. But if you use here the quantile height.na with na.rm equal to true, so it is trying to instruct that please remove the missing value and then try to compute the quantiles. So you can see here they are coming here like this, 0% first quartile, Q2, and here Q3, and here Q4. And similarly, if you want to compute here deciles, you simply have to give here props equal to sequence 0 to 1 by 0.01, and you get here these values, but for that you have to use here na.rm equal to true. And similarly, if you want to compute here this percentile also, you can use it very easily. And let me try to just show you these things on the R software also. So let me just try to copy this data here in the R software. So you can see here, this is your here data HEIGST.na. Right. So now if you try to make it here quantile of here height.na, you can see here it will give me error. But if you try to use here the command here na.rm is equal to here true, then you will get here the quartiles. And if you try to use here the option props is equal to sequence 0 to 1 and here say here by is equal to 0.1, then you will see here you are getting deciles. And if you use here the by value as 0.01, then you will get here percentile. And if you want to find out here the 47th quartile, then I can say here props equal to 0.47, and you can see here this is 145.09, which has actually changed, right? Because if you try to see here, if you try to use the earlier data set height, then you can see here this value was 145.03. Right. So now you can see here in this lecture we had talked about the aspects of quantile, which is very simple to understand and is based only on the concept of median. But it is very important. Important why? Because when the data is coming to you, particularly in the data set, when the data is very large, how will you get the idea that what is the distribution of the data? In which part the data is concentrated more, in which part of the data there is less concentration. All these types of partitions will help you. And if you are trying to compare two data sets, then you can compare their partitioning values in the respective data set. For example, the say 50th percentile of data 1 and 50th percentile of the data 2. If you try to see the values, they are the same, then you should be happy. For example, in the example which I took about the board examination, if you see that the 80th percentile of the two board examinations are nearly the same, then you can possibly conclude that okay, the difficulty level of the question paper or the marking scheme was almost the same. The level of difficulty was almost the same. So these types of conclusions can be drawn, and these are only the example, but sky is the limit if you want to take proper conclusion after looking into the data and depending on the objective. And this is what data science is doing actually. Just by dwelling different type of information from the same data set, we are getting such fruitful information which can be further used in many applications. But who will do this job? Only you. And for that you have to practice. So my request is that please try to take some data set, a small data set, bigger data sets, and try to see how these quantile functions are working. Try to take different data set or try to create two different data sets yourself and try to see how that difference can be diagnosed using the quantile values. And this will give you a very good idea and very good experience that by comparing different partitioning value, how can you judge about the central tendency of the data. So you try to practice it, and I will see you in the next lecture. Till then, goodbye.